This is a lesson 4.6, chapter 4 on arithmetic sequences. Let's go ahead and actually take a look at a sequence. Take the sequence -7, -14, and -21, and -28, and then it's followed by an ellipses. There's 3 dots. What a sequence is just merely an ordered list of numbers. What we're going to try to do is going to see if we can find some sort of a pattern within these numbers. Just a few things before we get on to the pattern. Let's go ahead and talk about how we're going to describe various parts of the pattern. So for example, this right here, the -7, is the first number, so it's what's referred to as the first position. Moreover, so you even take like -28, right? It's the 4th number over, so it's considered to be the 4th position. As -14 would be the 2nd position, -21 would be the 3rd position. We're going to take this as an arithmetic sequence, right? We're going to use capital A, and we're going to use a subscript as 1, right? 14 is going to be the term, second term. It's going to be A sub 2, right? And then -21 is going to be A subscript number 3, okay? Moreover, this is going to continue on to some sort of nth position, right? A sub n. So because -7 is in the 7th position, A sub 1 is equal to -7. We're going to refer to A sub n as the nth position. Next, in an arithmetic sequence, what we find is that what you can use to describe the pattern is what's known as a common difference. What's the difference between -7 and -14, as well as -14 and -21? Well, the common difference in all of these is -7, okay? So if we were going to find A sub 5, the next number after A sub 4, all we're going to do is take -28 and subtract 7. So that would wind up being A sub 5 being -35. All right. Something you're going to notice about these sorts of things, we're going to take a look at another sequence that's arithmetic, okay? We're going to take position, which is n, and then we're going to take the term, which is A sub n. So the first position we're going to have, right, is going to be 4. Second position we're going to have is going to be 8. Third position that we're going to have is going to be 12, right? 8, 4, 12. Fourth position, the term, the 4th term, will be 16. So the question being, is this sequence arithmetic? In other words, does it have a common difference? And of course, the answer is yes. It does have a common difference. That common difference we can see in between 4 and 8, we add 4. Between 8 and 12, we add 4. Between 12 and 16, we add 4. So our common difference is merely +4. All right, let's take a look at what this looks like graphically. So all we need is the first quadrant. And we're going to use the x-axis, or what's typically our x-axis, our horizontal axis, as our, to describe our position. And then our term is going to be our output, right? So that's where we're going to have A sub n graph. So here we go. So we have 1, 4, 1, 2, 3, 4. Let's see take a look at what that looks like here. And then we're going to have 2, 8, 5, 6, 7, 8. And then 3, 12, 9, 10, 11, 12. Okay, and as you guys can see, and then we'll even do 4, 16, 13, 14, 15, 16, right? Up here, so if we were actually going to connect all of these, right, it would be linear, right? So arithmetic sequences graphically are linear. This is something to keep in mind. So how are we going to actually solve an arithmetic sequence? Well, let's take a look here. Because the question being that if we're going to take, and we always like to do this vertical plotting, right? Because it's going to almost just look like a coordinate. So if we, let's say, have 1, right? And that's going to be our first position. It's always going to be our first term. But the way we're going to get, take our second position, the way we always get our second term effectively is the following. We're going to add that first term, the term that was previous, that first term, and we're going to add the common difference, right? Go back to what our sequence just was right up here, okay? 4, 8, 13, right? 4, 8, 12, 16. Our third position, right, which wound up being 12, well, a sub 3, the way we got it is that we added a sub 1, but what we really did is we did twice the common difference, plus 4, or 2d, right, which was 8 total, 4 plus 8 being 12. If we're going to get 4, it's going to be a sub 4, which again is going to be that first term, plus instead this time is 3d. All right, well, algebraically, like how could we get like the nth term? Because where we're going to have a problem is if we want to do a sub 100, right? The problem being is that that's going to just be rather arduous to solve. Of course, you could go and lay out 100 terms, okay? Like you could take out 100 positions and then continue on successively adding 4 each time, all right? But we want this to work for really any sequence, not even just one where we know is just kind of counting by 4s. So in this case, we're going to have 4 sub 4, that's strange, a sub 4. It's going to be a sub n, okay? So any term, well, we always start with that first term, a sub 1, but notice what we're doing. Here, right, when I had a sub 3, I multiplied by 2. Here, where I had a sub 4, right, I was multiplying by 3. So now I have a sub n, right, and then since 3 is 1 less than 4, 2 is 1 less than 3, what we need to do is 1 less than n in this case, and we're going to multiply by that common difference. And right here, now we have a formula that we can use as an equation for any given arithmetic sequence. It's pretty cool, because this one that was counting by 4s was pretty straightforward. Let's actually do something that's a little bit different here. Let's take a 7, 3, -1, -5. And again, it's that whole thing of if I wanted to find what a sub 100 is, I don't want to have to sit there. I mean, if I paid you $1,000, right? You'd sit there and write out 100 positions and then figure out every single term starting with 7 and subtracting 4 and do that 100 times. But there's got to be a better way, right? So let's figure out what that is here. Let's go ahead and do the following. We have our common difference, -4, -4, -4, right? So our d here is equal to -4. So to figure out what a sub n is equal to, well, let's use our new equation here. What's a sub 1? Well, that's my first term here, 7. So here we go. That is my first thing that I'm going to have here in my equation, plus n minus 1, which I don't have, right? Still trying to figure out. Then I'm going to multiply times my common difference, which is -4, okay? And I'm going to have to go here and I'm going to have to multiply that guy back in. So I'm going to have 7 plus -4 times the quantity n minus 1, right? Multiplied in to get 7 plus, and rather than plus, what's -4 times n is -4n. And then -4, right, times the -1 is going to be a +4. Of course, I can combine these two terms here. And then we're going to have -4n plus 11. And there we go. So, rather than thinking about, again, a sub 100, which was, again, a sub 1 plus whatever, it would have been 99d, right? Well, that's problematic here, having to, trying to calculate that. That's going to be, again, us thinking about that over and over and over. So instead, what we can do here is to figure out the 100th term, all we have to do is plug in 100 for n, which is going to be negative 400 plus 11, which winds up being negative 389. So I didn't have to count up at all. And this would work for, any term in the sequence. We find the 1000th term, or we can even just find the 5th term, which we already know here is going to be negative 9, right, after the negative 5. But again, plug in the 5 here. If we want to find what a sub 5 is, we're going to say negative 4 times 5 plus 11, which of course is negative 20 plus 11. And again, it's going to be negative 9. Okay, so probably easier just to subtract off 4 if we're already given that much of the sequence. But again, if we're trying to look for something further down the sequence, it's going to be a lot tougher. So let's go ahead and write some equations here. Give a few examples here. And we're going to write the equation for the arithmetic sequence. Works like this. It's going to be 4, 2, 0, negative 2. Well, first, we need to figure out what our d is. Our d in this case is negative 2. All right. So again, using that same formula, a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Okay. And in this case, a sub n is going to be equal to, our first term is 4 plus, again, we need to find n minus 1. But our d we already know is negative 2. So we're going to go ahead and distribute that guy. So we have 4. Okay, negative 2 times n is negative 2n. Negative 2 times negative 1 is positive 2. So then we're going to combine those together, and we're going to get negative 2n plus 6. And there you go. We have our equation here. Let's try another one. Let's do negative 12, 0, 12, 24. So it's our sequence. Again, first step, let's figure out what our common difference is. In this case, to get from each term, from one term to the next, we're going to subtract 12. So our our common difference d is negative 12. A sub n is going to be equal to our first term, negative 12, a sub 1, right? Plus quantity n minus 1. Okay. And we're going to multiply here times our common difference. Oh, I'm sorry, it's not negative 12. Our common difference is positive 12, right? We added 12 each time. It's going to be 12, okay? Make sure we clear that up. I'll make a simple mistake. So negative 12 plus 12n. Negative 1 times 12 is negative 12. So then we have here 12n. And then we're going to combine these terms. That's going to be negative 24. All right. Negative 2, 6, 14, 22. All right. So again, let's find our common difference. Let's make sure we get the right sign on it this time. Common difference from negative 2 to 6, from 6 to 14, from 14 to 22, we're adding 8. So it's going to be 8 this time. So let's go ahead and find our equation. A sub n, our first term is negative 2, okay? So then we're going to add, and we're going to have n minus 1, and then it times our common difference, which is 8. So this should be like an old habit might now. We have negative 2. We're going to distribute that 8, right? 8 times n is 8n. 8 times negative 1 is negative 8. Combine our terms, so we're going to have 8n minus 10. And there we go. All right, let's do one more little problem here. So we're going to take this word problem. We have Bill saves $15 the first week of the year. And savings each week increase by $6. So we write a function that represents the arithmetic sequence. Okay, so let's actually take kind of a quick little look at this. So we're going to have his week, and we're going to have his savings next to each other. So making sure we understand this is arithmetic. So Of course, we have n, and we're going to say I have a sub n, as long as this is arithmetic. So let's take a look. So week 1, 2, 3. In week 1, he had 15 bucks. Okay? Then he increases his savings each week by $6 more. So $6 after that is going to be 21, right? After that, week 3, he'll have 6 more bucks, which is going to be 27. So here, our common difference is going to be 6. And again, this is arithmetic since there is a common difference. Increases by 6 each time. So our function is a sub n. First term is 15 plus, and then we're going to have in parentheses n minus 1, and then again times our common difference. And we're going to distribute that guy back. 15 plus 6 times n is 6n. 6 times negative 1 is negative 6. Combine your terms. And then we're going to have 6n. And then 15 minus 6 is going to be positive 9. So there we go. All right. So let's go ahead and consider one more option for Bill here. Let's see how many weeks. Let's see if we can work backwards here until he's got 75 bucks, something that he's saving up for. Okay. Well, how do we do that applying to, to Bill's savings pattern here? Well, what we know is that the outcome is going to be 75. That's going to be a sub n. That's whatever term he's going to be on. So we have to apply that to our equation up here, which again, this is what a sub n is equal to. So we're going to replace a sub n and substitute it with 75. That's going to be equal to 6n plus 9. So we're trying to figure out, again, n right here is the number of weeks. So now we just need to solve. So minus 9 minus 9. 75 minus 9 is 66 is equal to 6n. So 11 is going to be equal to 10. What does that mean? Well, it means that it's going to take just under 3 months. 11 weeks total. All right, go ahead and get started on your homework for section 4.6. Good luck.